4 parentheses negative x. Oops, I said parentheses. It's not voice activated yet. Okay, make sure you get something that looks like this in there, and then whenever you're ready, click on graph.
Okay, it worked.
And it should work. And then you're just looking for the one that matches that, which is option B. And it is that simple. There's nothing more complicated than that about this. Okay. Moving on to the next one here. This is a by hand problem. There's not really a good way to do it in the calculator. Well, it kind of is, but we'll see. So there's a property of logarithms that says if they have the same base and you're adding, you end up multiplying. So the sum becomes a product. So on the left, this becomes log base b of x times x minus 4. And this equals log base b of 21. So now you set the inside part, x times x minus 4 equal to 21. So there's a couple of ways you could solve this. The best way is you're comfortable factoring, and you move this 21 over to the other side. The best way is to factor this. Now, if you're like, hey, I don't think I'm going to be able to do that on the test, you could graph this. You put that in your y1, and you could figure out where it hits the x-axis. It doesn't matter to me. So if you're like, hey, Matthew, that's what I'm going to do, like we can do this. Or do you want to try factoring this?
I think I can factor it.
All right, so two numbers that multiply to negative 21, but then add to negative 4, just because I don't want to
3 and
use up
7.
yeah, and you have to figure out which one's positive, which one's negative. So it ends up that you set them equal to 0. So you get x is 7, x is negative 3. Now you might think those are the answers, and they seem to be the answers, but you're supposed to go back and check them because you cannot take the log of a negative number. So you typically exclude the negative, typically.
Okay.
So it's just 7. Just 7.
All right. All right, that was right.
Okay. So this problem here, we're going to do in the calculator. Now on your multiple choice, you would just try the answers if it were truly multiple choice. What I'm really hoping for your sake it is, because it makes it so much better. But for us to do it, kind of to show you on the graph how you might do this, is you put into y1, the first one, 3 caret x plus 2. Y2 is 8 caret x. So I'm going to go to the calculator. We're going to graph it then and find the intersection. So, I mean, you probably will not need to do this on the test, but you're welcome to follow along if you would like.
Okay.
So 3 caret x plus 2. 8 caret x. I got a graph. That's the hard part. We'll see if they actually intersect. Yeah, so this is not really ideal, but I'll just show you anyways. So second, how can you just follow along? Intersect 5. And so you say, okay, first curve, I'll just use that there. It doesn't really matter. Second curve, there's a second curve. Guess.
First curve.
And there's the intersection point. 2.240. 2.240.
I hit intersect, but I only got first curve question mark. What do I do?
Just hit enter and enter.
Okay.
You can just, because there's only one place to intersect, you don't have to actually be all that specific about it.
Okay.
But I do think you'll be able to just try the answers in the when you get to the exam.
Okay.
Did you get 2.240 there, like I'm showing?
Uh-huh.
Okay.
It says round to 3 decimal places. So 2.0.
And let me know if there's more than one part, because I didn't
Okay,
snip that in any of these questions.
not on that one.
All right. All right. So the present value here formula is you take the amount that you're given and you divide it by 1 plus the interest rate, 0.1 to the t, right?
Okay.
So this is where sometimes entering in the calculator is a huge challenge. So the present value is the amount over 1 plus r over n to the n times t. But in your problem, n equals 1 because it's annually. It's annual. So in terms of how to enter this in the calculator, it's 400,000. Yours might have the nice fraction in it. I don't know. If you don't, you have to do it this way. 1 plus 0.1 caret 20 like that. I'm happy to show you that in the calculator if you need, but maybe give it a try on your own. And I'm also going to
Plus.
do the calculation.
All right, I got 59457.
Yes, 59457.45.
Yeah.
Yep. All right.
So
So
when it
basically
says
they're saying
less
like,
than appropriate cent, what does that mean?
say that one more time, to 2 decimal places. Sorry, two
Okay.
decimal places.
Oh, just okay, that makes sense.
Just like money. But that they could be a little bit more clear. Just say 2 decimal places.
Okay, that was right.
All right. I think this is one of the first ones that has more than one part to it.
Yes. This one.
All right. So the graph of this is a piecewise graph, and 11 is horizontal. You can see that all three of these are horizontal at 11. Okay. For the middle one here, what you really want to do is evaluate it at each endpoint. So at -1 and then at 3. So that's -1 squared plus 2. Make sure you substitute in parentheses and so we're trying to figure out like is it down here or is it all the way up here? And you can see that that's 3. That means that A is out because it's, there's 3 and there's 3. Okay. Now, could you look closely and you can do it maybe easier on your screen. What is the other difference between B and C?
Uh,
It's a small difference there.
oh, the point on the left, the one on like 11 is closed on the first one and open on the or the opposite. It's
Yeah, they're flipped. So that comes down to the inequality. So when you see this less than right here, that's an open circle. So
right.
that means that letter B is the best choice there because
Okay.
that open circle corresponds to, let me see if I can get right there.
Okay.
And then the less than or equal to, that corresponds to that there.
Okay. Okay, that was right. Then it
Right.
says
What is part B?
select the correct choice below and if necessary, fill in the answer box. The function is discontinuous at x equals, or the function is continuous for all values of x.
Okay, so it's discontinuous when there is a jump,
Okay.
whole, or vertical asymptote. You have a jump and it's the x value. So the x value there is -1. So at -1, there is what's called a jump.
Okay. All right. And then C is find the limit or limits from the left and from the right for any values of x found in part B. And then the two options are the limits from the left are blank and the limits from the right are or no discontinuities, but it's not
Okay,
that.
so yeah, so this is saying like now figure out what the limit as x approaches -1 from the left. So this is from the left up here where my cursor is. Like what's the y value where this hole is?
11.
And then the limit as x approaches -1 from the right is the y value as you're coming down this way. What's the y value
Uh,
there?
3.
3, yeah. So those are the two that it's asking for.
Three. Okay. And then that was the last part.
Oh, good. That was it. All right.
Yes.
Wonderful. All right. Okay. So the instantaneous velocity equation has to have a limit in it. You have to associate instantaneous velocity with limits. That means that B and D are out. Okay.
Okay.
The other thing you're looking for is a subtraction, which they both have, but it's this limit as H goes to zero. That's key. So that is the correct answer here. So you want to somehow mentally remember that, because I do think they tend to ask a question like this. It's not really that difficult as long as it's a choice. You just have to somehow remember that instantaneous velocity is this limit as H goes to zero. H. Very important there.
So it's always H.
Always H.
Okay. Let me just write that down. Okay, that one's right.
All right, so we're going to go back to your calculator for this one. Your calculator has this really cool thing. It's called math. Let me.
Oh, sorry. There was another. I totally didn't see that. It asks the second part is the instantaneous velocity at t equals 3 is
Okay,
blank.
good. So that's actually related to what we're about to do here. So under math, let me just look for it. Okay, yeah. So we're going to go to your calculator, math, and then n deriv, which is number 8. So we're going to do that together here. But what this does is it takes the derivative, but it doesn't give you the actual derivative. It just evaluates it at a point.
Okay.
All right, so I'm gonna go back to the calculator, and we'll take a look at how to do this. So you go to math, and then you go down, or you can go up to n deriv like that.
Okay.
N deriv. Okay, so you hit enter. Now yours might have a screen. I don't know
Yeah,
what.
mine says it has d divided by d and then blanks. Like,
Yeah, so you want to put x in the bottom there. So like dx,
okay.
and then you're you have to type in the function that you're going to take a derivative of. So it's 3x squared plus 4x plus 2 comma x comma 2. So yours probably says when x equals and then you want to put a 2 in there.
Yeah, so 2 in there. Okay. And then sorry, I'm just still typing this in. X comma 2 x equals 2.
It's 3. Sorry, it's not
Oh,
2, it's
okay.
3. That's the next one. So you want to edit that. So it looks like you get 22.
It sent me to syntax error.
All right, let me go. You're using a TI 80.
84 plus. 84
Plus.
plus. Sorry.
Let me go look, and I'll grab a screen capture of what you should type.
Okay. Do you want me to share my screen and show what it is?
No, I'm trying to get to the calculator screen so that
Okay.
I know what you're seeing, because it's
Okay.
different on every version of the calculator. Um, yeah. So here we go. This is what I was looking for. Google saves us again. Okay. All right. So I'm gonna go back to the other screen and show you what to type.
Okay.
All right. So this first box gets an X.
Okay.
And then this middle one here is the thing you're taking the derivative of, which is the 3x squared plus 4x plus 2. And then you have to put x here again, and then 3.
Okay.
So do all that, and you should get 22. If you don't, please let me know.
Okay.
Try something else.
X plus 2, and then x equals 3, just 3, or do I have to write x again?
Yeah, you have to put X again. It's whatever the number is.
All right, I got 22.
Fantastic. It's that easy.
Sweet.
Okay. All right. So the next problem is really similar. And this is all instantaneous velocity. So that's your keyword that you're looking for here. So when it says instantaneous velocity, what it's really saying is derivative at a point. So you're going to use the same end deriv again. And so it's x again, x, and then it's 4x squared minus 4x minus 9. That's this here. And then x, and this time it's 2.
All right. Just 1 second. All right, I got 12.
Okay, go ahead and try it.
All right, that's right.
All right, so we're on to the next one here. And you might think, oh, I've got it. Like it only, I'll tell you as much as we can. You can use the calculator as much as we can, but this one, for the first part, you have to do this by hand.
Okay.
But for the other parts, you can do this using end deriv.
Okay.
All right, so no, good news, bad news, right? So the derivative of this function is the power rule, d dx of x to the n. And if there's a constant in front, it's n times the constant, n minus 1, like that. So we did a bunch of these, I think, last time, but you bring the constant or the exponent down, and you subtract 1.
Okay.
Remember us doing that?
Yeah.
d dx of a constant times just x becomes just the constant. So for the 9x, it becomes just 9. Sorry, just 9.
Okay.
The derivative
And
of a
-4
constant,
gets 0.
yeah. So minus 2x plus 9 goes in that first box.
All right.
Okay. Now while you could use end deriv on the original, you can also just evaluate this at each of those points.
Okay.
And that's what I do for part, B, and C.
Okay.
I would find f prime of 1 by putting 1 in for x. Okay. Or you can use end deriv, but you have to do it from the original.
Okay.
And that's where you could maybe be unclear. It's like, oh, when am I using the original? When am I? It's up to you. There's
Okay.
2 options.
I think by hand is probably easier, so I don't get confused.
I think I would agree, especially because this one is not that complicated for
Yeah.
relative to maybe some others.
Just because that's how we practiced it, so that's what I remember best.
Yeah, we did a couple of these. If you look back at previous videos or notes, you'll see that. All right, so those are your B, C, and B, I believe.
Hello?
I'm still here. Everything okay?
Yeah, I just got a call. Hello? Yes. Oh, who are you calling on behalf of? Sorry, that was just a spam call.
No
I
problem. If you ever need to step away, just let me know.
Yeah, I figured that's what it was, but okay, so sorry about that.
Let me know when you get that down. We'll look at the next one.
Okay, perfect. We can move on.
All right. Yeah, I guess we'll just do these in order. Let's see why. Okay. The equation of the secant line always has this form: f of b minus f of a over b minus a. And B is bigger than A. So like the first number should be bigger than the second. But only one of these actually has the right form, which is this one down here. I know this is a multi-parter, so just let me know what part B is. Probably actually to calculate the tangent line.
So the secant line is blank.
Give that to me one more time. Sorry, what does it say?
It says the equation of the secant line is blank.
Okay. Interesting. Okay, wow. So we actually have to calculate these. So f of 6 means to put 6 in for x, 6 squared plus 6. F of 2 is 2 squared plus 2. And so the slope, which is the secant, which is what we just did up here, is 42 minus 6 over 6 minus 2. Okay, so that's just the slope. Does it say y equals and then a box, or is it just a box?
It's the box.
Just a box. Okay. So the best way to do this is to use what's called point slope form. Y minus y1 equals slope x minus x1. The slope is what we just calculated. And then you can either use the ordered pair 6, 42, or 2, 6
2 and 6.
as your x1 and y1. I would use the second one. It's a little smaller. So y minus 6 equals 9, x minus 2. It should accept this. If it doesn't, let me know.
Okay.
We'll try to correct it.
Okay, that was right.
Excellent. Okay, is there a part C?
Yeah,
Or
it says
the part B?
the tangent line.
Ah, darn. Which x value? Oh, the first x value. Okay. So let me grab a snip of to kind of reset the problem here a little bit. So the tangent line requires a point and a slope. So the point is when x equals 2, we already calculated that y is 6, just putting 2 in for x. So that's our point, 2 comma 6. The slope is really the derivative at a point. And that's where you use n deriv. Or you can do it by hand. So you either have to take the derivative using the calculator, evaluate it at 2, or do it by hand and then evaluate it at 2.
Okay,
Which would you prefer? Say that again?
N deriv on the
Okay,
calculator.
so use n deriv and tell me the derivative when x equals 2.
Okay. Got 5.
That is correct. So that's the slope. The slope is now 5. And then you can do the same thing we did in the previous problem here. So the x1 and y1 are the same. The slope is this time 5. So y minus 6 equals 5, x minus 2, like that.
Okay, that was right. And that's the last part, thankfully, on that one.
Cool. Okay. We're up to kind of a graph here. All right. It says determine where the derivative is equal to 0. So it's equal to 0 at what are called horizontal tangents. There are 4 possibilities. There's the min, there's the max, there's when it kind of comes up to a plateau or comes down to a plateau. I'm just seeing one right there. And you're looking for the x value there, which appears to be 2. This other point is a corner. This is where it's not differentiable. And we saw that in an earlier problem where you had to figure out where it's not differentiable.
Would that just be 0 or 6?
Well, no, it just that one doesn't apply to this. So like it's
Oh,
we did a problem earlier. I think it was where I we did it on the screen where you were sharing your screen. I just, oh yeah, it's just where there's like
okay.
it came down like that, like a cusp,
Yeah,
call it cusp. So like that's a separate problem, kind of, where it's could be asking that.
okay.
All right. What's part
That
B?
was
There's
incorrect.
what's that?
It said that was, oh wait, I kept the comment there. Never mind, that was my fault. 2 was right. Okay, and then B is determine the x values where f prime of x is undefined.
So we just did that. So it's that X value there, which would be 0 at the corner.
Sweet. And then C is determine the open intervals where f prime of x is greater than 0.
Okay, so let me grab the graph to do C again one more time. So the derivative greater than 0, what that means, what that's referring to is where it's going up and to the right, where the graph is going up and to the right, f prime of x. So I'm going to highlight those and then we'll talk about how to write them. It's all of this and then all of this. So it's again, it's the x values. It's only the x values. It's not the y. So from minus infinity to 0, that's the first yellow one here. It's going up and to the right, comma, and then the second one is from 2 to infinity. 2 is the start, again, the x value, not the y value, to infinity, always to the right.
All right, and that was correct. And D is determine that open intervals where f prime of x is less than 0. Or yeah.
Yeah, so that means it's decreasing, it's going down and to the right. These are definitions to remember. Okay, and I'll do that in a different color here. Looks like we'll go with red. Everybody likes red, but that is the color there. It's from 0 to 2, and it's the x values. It's always the x values,
Okay.
never the y's.
Right, that was right. And then the last one is sketch a graph of the derivative.
Oh boy. Okay. Never-ending question. So in terms of our time, if they got like 5 parts, sometimes it's not as good as doing the one that's got 1 part. But the derivative is a graph of the slope. Okay, and the first thing you identify is where there's a 0, which is right there. Okay. And then you look at it and you break it up into these like sections. So in the first region here, the slope of this line is always a positive number. It's something like, something like that. It's horizontal because it's whatever the slope is. The slope is actually 1. So there's some sort of a line there, y equals 1. And then the second one goes down, in the second region number 2, it's going down. So it's going to be below the x-axis. So something like that. And then it comes up like that. Could be a straight line also. I don't really know what the options are.
Okay,
Maybe
perfect.
that's enough to get that
Yeah.
for now. We would need more discussion to sort of explain why that's correct. But let's keep going here. So a couple more here. All right, so when you're looking at this graph here, it says it says to graph the derivative of the function graph to the right. So the first thing is you look at that place where it hits the 0. So there's only one place that it hits 0. So that means A and C are out because that place where there's a horizontal tangent is the only one where it's going to be a 0. Okay. The next thing is to look at whether the graph is increasing or decreasing. when it's going down and to the right, it's always decreasing. So this graph is always decreasing.
Okay.
And what that means is the derivative is always below the x-axis. That's why B is the best choice, because the derivative is always below the x-axis.
Sweet.
There's no way to kind of pattern this because they could give you like a graph going slightly the other way. These are one of the most challenging topics for most students to remember. So I don't have a great solution, but all right. So the next graph here, kind of there's this break point in the middle there. Um, the in region 1, the graph is increasing, which means the derivative is going to be above the x-axis. So we can eliminate any that are not above the x-axis in the left there. So this one is out, and C is also out because it kind of goes down like that. So we're looking at either A or D. In region 2, the graph is decreasing, which means that the derivative is going to be below the x-axis. So that means it must be A because it is below here. See how this one's below and this is above. It literally is just that.
Sweet.
All right. This is a good stopping point for us. So we'll need to, in the next hour, I've got some questions, but we need to keep grabbing some more. Usually get through around like 15 to 20 per lesson. So we'll stop here. And I know it's annoying, but please use that other link for 1 o'clock, and I'll see you in about 10 minutes.
Okay, sounds good.
All right, thanks. See you
Okay.
shortly. Bye. Bye.